All right, hello, and we're going to do a quick demonstration of how we can use 3D point cloud technology to take a scan of a site and translate that information into a BIM software like Revit, and we can use that as reference information to start to build out a 3D BIM model in Revit. All right, so let's get going. So the first thing that we would need to do to get a scan like this is that we would need to go on site, and in this case we would be scanning a warehouse, and in this particular warehouse the idea is we would we want to capture this building here, and in order to do that, to capture this building, we would probably take a scan from this point, maybe from the front, and maybe from this side, and that would be able to pretty much capture everything as 3D point cloud within this vicinity. Now we're going to take a look at what 3D point cloud is, and there is a bit of a process to go from scanning to get it in the point cloud software, but essentially point cloud gives a three-dimensional visual that's accurate down to the millimeter of an area that is scanned. So you can see where the scanners are, right? So in this case the scanners are located here, here, and here, and they all do a 360 degree scan, and that is why it's able to capture all of these points here. You can kind of see where the detail is fading off in the distance, and the idea of this is that each of these points here are laser points that's being collected by the scanning device. Now this is really awesome because these points capture everything. If you look closely here, you can even see the persons that were on site watching while the scanning was happening. You can kind of see the figures outlined here because when it was being scanned, it also scans the persons as well as you can see that it scans this area here in a high amount of detail, right? And you can see all that detail down to the column work, the structure, and the siding material. All of that information is captured, right? And in this case there's actually some material that's located in this warehouse here, and then on the periphery you can see where it also captures other elements that are on the site, including even elements that are far off into the distance, as you can see here, right? Now the closer you get to the scanning node is the more detailed the scanning is, and what actually happens here is that multiple scanners overlay, so you can kind of see like a greenish hue here, and then you can kind of see like a bluish hue here, and this is because each color represents a particular scanner, and where the colors overlap, so you can kind of see the colors overlapping here. This is actually very good because that means that there is an overlap of the scanning, and that overlap helps to make the scanning process more accurate. Now speaking of accuracy, one of the benefits of being able to scan as a point cloud is that you can get every measurement down to the millimeter, right? So for example, if I wanted to get certain measurements, maybe the width of this warehouse, I could simply grab any of these points here, and you can kind of see where it's hovering over the point, and then I can grab any point on this side, even if it's not 100% perpendicular, right? And then you can see where it gives a perpendicular distance along with a diagonal distance, right? So and it's down to the millimeter, right? And that is this is the beautiful thing about this, because each of these points are accurate to the millimeter, And the process of putting this point cloud together, which is called registration, it actually goes through a kind of check-in workflow where it tells you just how accurate the points are to the real world. And this particular scan was 100% accurate. And one of the things that makes it accurate is, setting up the total stations, which are these tripods, what you see here, setting up those accurately, and also allowing the scans to overlap. And when they overlap, they kind of correct themselves to give you 100% accuracy. So that is how we can get measurements, and we can measure any point with this point cloud that's here. Now, the other thing that we're going to do is we are going to carry this point cloud into a program, into a BIM program, in this case Revit. But before we can carry this into Revit, we need to export this in a format that can be read in an Autodesk program called Recap. And this is Autodesk Recap. And what it is a program that allows you to view point clouds from different file formats. So for example, you can see here I'm able to view the point cloud that I imported from the previous program, which was Trimble RealWorks. Now you might notice that the point cloud here is a little different, and this is because you can actually tune the point cloud to give you detail in areas that matter and low detail in areas that don't matter, right? So there was a little bit of tuning that happened here. So for example, if you look back on the original point cloud, this is in Trimble RealWorks software, you will see that there is just a general distribution of the point cloud, right? And this particular point cloud could maybe be upwards of maybe 500 million points, right? These little points that you see here. But in order to use it in a BIM software, we don't necessarily need all those points, especially for areas like flat walls that are basically flat. We don't need to be generating all those points there. So there you can actually tune the amount of the way that the points are distributed, and that is how we're able now to get this to have detail in areas that matters, like the columns and the roof, and less detail in areas that don't matter, like flat walls and so forth, right? All right, so after we have this here, we now will link this to Revit, right? And this Autodesk Recap Pro file is compatible in Revit, and it will be read as a point cloud file, right? So you can see here that we're in Revit, and we're able to have the point cloud as a reference, right? While we use our wall tool, and we can now essentially trace just as how we would trace if we had taken measurements and field notes, and we would have to use those field notes to construct a model. Now we're using the actual point cloud 3D model as a reference to trace. And there are many things you can even manipulate the point cloud. So for example, let's say that I only wanted to see a particular section of the point cloud. There are many different tools that can be used. So for example, I could clip my point cloud to only this area here, and now it only shows me this section here, which is great if I want to go into a top view to help to trace out a plan showing what we have captured in point cloud, right? So at this point here, what we're doing is essentially using the point cloud as a reference to recreate our existing building in its most accurate forms, and we would also be recreating all of these structural members that matter using actual BIM tools and using the point cloud, which is 100% accurate, using that as a reference and essentially drawing over the point cloud with the actual tools in the BIM software, right? So this definitely makes the efficiency of doing a digital measured survey and being able to produce a BIM model from that. So that was a quick overview of how we would use point cloud in a BIM software.